Welcome back, guys, in the Data Science 24/7 channel. So, we are going to continue data visualization. So, in the previous videos, we have gone through for this data visualization, it's important. Then, types of chart and types of chart we have covered, comparison chart, composition chart. In this video, we are going to cover relationship charts and distribution chart. So, relationship chart, bubble chart. The first chart that comes under relationship chart is bubble chart. Let us begin. So, a bubble chart, also known as bubble plot, it's an extension of the scatter plot. Used to look at the relationships between three numeric variables. Each dot in a bubble chart corresponds with a single data point, and the variables values for each point are indicated by horizontal position, vertical position, and dot size. So this chart is used to add another metric to scatter plot. So actually the scatter plot is another plot that is used to show the relationship or the distribution of two quantitative variables. But what if we have another quantitative variable also associated with these two quant variables? Then there comes bubble chart. Why bubble chart? Because here we can add three numeric variables. Let me show you how. So this is an example of bubble chart. So the first metric is strategic importance, that is on x-axis. On y-axis we do have complexity. Then these are the categorical variables, and each bubble is showing each categories. So here you guys might be thinking, where is the third numeric variable? The third variable that I am talking about is categorical. But let me tell you, the size of this bubble is showing or depicting the third numeric variable. The smaller the size of the bubble, the smaller the value. More the size, higher the values. I hope you guys understood. Apart from this, a bubble chart is created from a data table with three columns. Two columns will correspond with the horizontal and vertical position of each point, as you have seen, horizontal and vertical, while the third will indicate each point size. Okay, as I have told you, the third will indicate the bubble size. One point will be plotted for each row in the table. Yeah. So I guess that is all for the bubble chart. So guys, actually bubble chart comes under relationship charts, as it is telling the relationship between three numeric variables. So the third and the second relationship chart is combo chart. So guys, as the name itself is suggesting, combo means combination of something. So it can be a combination of two column charts, two line graph also, line chart, and then it can be one column, one line. So you can make a combo chart with a single dataset or with two datasets also that share a common string field. So here please emphasize on this part, that is, we can make a combo chart with a single dataset or with two dataset that share a common string field. Let me tell you. Guys, I think what should you do right now? Please pause the video and try to analyze by yourself, like what you are analyzing from this graph, how it is combo chart. So it is a combination of column chart and a line chart. Like I have told you, a combo chart can be two columns, two line, or one column, one line. So it is a one column and one line. Like one metric is shown with the help of column chart. Okay. The another metric that is on the secondary axis is shown with the help of this line graph. Then if there is two data set, that there should be they should share a common string field. So guys, can you guess where what is the common string field is here? Yes, it is quarter and year. This quarter and year is sharing a common string field. So we need to analyze price and volume quarterly for year 18, 19, 20. So for quarter 1 2018, the volume was around $150. The price was around $75. It is how we interpret the combo chart. Uh, so folks, please once again try to gain some insights from this combo chart after pausing the video. It is also as simple as the previous one. It is also showing a combo chart contains one column, one line graph where the primary axis is showing sales and secondary axis is showing ads, number of ads, and the common field is months. Correct. For any year, it is a month. So here also we will interpret like the same as before. Like for January month, sales is around 90K, and this how many ads per line? It is around two, two ads. So this is how we interpret. So this was guys relationship charts. So with the help of these charts, we were gaining some insights on the basis of relationship. And let us move to distribution charts, and one of the most important graph or charts in data science field, because like while doing linear regression there is an assumption that error should follow normal distribution. So how do we detect that whether error is following a normal distribution or not? So generally or maximum we like plot a histogram of error field and we get to know its distribution. It comes under residual analysis also. Okay, so histogram is a frequency distribution that shows how often each different value in a set of data occurs. A histogram is the most commonly used graph to show frequency distributions. It looks very much like a bar chart, correct? But there are important differences between them. Okay. The important thing, most important thing, the data should be numerical or continuous. But what happens in bar chart? A bar chart is made for the categorical variable, but histogram is made for the continuous variables. Now we want to see the shape of the data's distribution, especially when determining whether the output of a process is distributed approximately normal. Yeah, like like in error field, what we need to know whether it is following a normal or not. So histogram plot data with ranges of data grouped into intervals called bins, while bar charts are used to plot categorical data. Yeah, that I'm telling you. So this is how a histogram looks. Okay. So here we have two continuous data, quant variables, and we are plotting its distribution. So uh, what insights can be derived with the help of histogram is its distribution. That is whether it is following a normal graph or not. Here, it is looking properly symmetric, right? If it is looking properly symmetric, then what does it mean? It is a normal distribution. So basically, it is a histogram. So with the help of histogram, what we can infer whether a variable is following a normal or not. Let us look on another different types of histogram. So one histogram we have seen here. It was a properly symmetric and hence known as normal. Now here, suppose a histogram is showing a skewed distribution, like in the earlier x-axis, it is very getting higher, and while moving ahead, it is getting lower. So it is a right skewed. It is shown as right skewed. Similarly, it is shown as left skewed. Since it is very higher in, it is lower in left side. Here it is lower in right side. That is why it is a right skewed. It is left skewed. Now it is similar to previous graph. It is also symmetric, right? So it is a normal distribution. So here it is written unimodal. Why unimodal? Because it is giving only one highest frequency. But in this graph, we can see on different x-axis or on different values of the x-axis, it is giving two higher values. One around 110, one around 120. So since it is having two higher frequencies, it is known as bimodal. Here, for different values of x-axis, it is giving different modes. Like one is around 90, one is around 120, one is around 110, then again 115. So this histogram is telling that data is having multi-mode. This graph is showing it is uniform. It will be showing as a uniform graph, like the data is distributed uniform. So this is all about histogram, guys. Now we can move ahead. So the last thing that is left is it is scatter plot. So basically, it will come under distribution charts, but it is heavily used to detect the relationship between two quant variables. But it comes under distribution chart only, so we can have a look. Yeah. So a scatter plot, also known as a scatter chart, scatter graph, uses dots to represent values for two different numeric variables. So the position of each dot on the horizontal and vertical axis indicates values for an individual data point. The scatter plots are used to observe relationships between variables, basically between two quant variables. So here we have a scatter plot. Suppose on x-axis, sorry, on x-axis we have one quant variable. On y-axis we have another quant variable. So we can see the dots are linear here, like heavily it is distributed around one straight line. So it is showing that it is a positive correlation. Okay, here. So here what is happening, like when the x is increasing, y will also increase. It is showing that. That is why it is a positive correlation. Here what happens is the x is increasing, y is decreasing. So it is a negative correlation. See, the x is increasing, the y is decreasing. So it is a negative correlation. Here the dots are scattered randomly. There is no any sign of pattern. That is why x and y is not showing any kind of relation. So this distribution we can name it as a random distribution. This will be known as positive correlation or linear distribution. It is also linear but with a negative correlation. I hope you guys understood the scatter plot very well. It is also used heavily in data science. Like scatter plot is used in data science and heavily, like whether suppose we need to detect distribution, relationship charts, even in getting outliers, we use scatter plot heavily. So that is all from my side in data visualization. I hope you guys have learned and find it insightful. If you do like this video, please share, subscribe, like this channel. Thank you.